Hey there, this is Hugo Dememe recording for the Project 2 Process Scheduling project, and I want to show you how I ended up building out this project. So if you look here, you'll see that the first thing I did when I booted this machine is actually set the allocations to different levels. So the first thing I did is look for the bash process, because the bash process automatically opens quite a few force quite a few times, which allows you to actually find processes that will run in other levels. So the very first thing I do is basically set by giving it its process, the bash process ID. I can actually set its tag to 1, which is one of the things that this test function does. And then these last two numbers actually set the allocation. So level 1 is also set to 100 milliseconds. Level 0 is to 5, 2 to 30, and 3 to 30. And what this will allow is, if we look down this list, although it isn't common because the 0th level actually runs the most, considering it's every process except the bash currently. But we will find, I believe it's down here somewhere. We will find processes that aren't the idle and that actually run. And on the other hand, let's look at the actual implementation inside of the kernel of this. So if we look under, let's find it, come on. Yeah, and it's also, as you can tell, it's also running quite a bit slower because obviously I've been working with, so it actually sets the allocation to be quite a little lower. So the system calls were made, and you can basically see all the requirements that we were told to do. The fact that it needs to be non-negative, the fact that the levels need to actually be 0, 1, 2, or 3, that some of the allocations need to be under 5 milliseconds, but that's not the important part here. So the get alloc that retrieves, but here's that it was actually implemented. So in order to make sure that we actually got, so when I first tried implementing this, I started adding a lot of, I started trying to DQ and NQ, but the problems I kept finding that I kept breaking the machine. And basically what I ended up deciding to do is to see if you could basically let the scheduler do what it normally does, but trick it into using the levels. So I gave it a loop using a go-to function, which is down here. And basically, it only loops back up to the top of the schedule function when the next process doesn't have the current level, and it's not the idle process. So it'll stop and actually get to the end if it is the idle. So the idea is basically up here, right here, the scheduler actually goes to the next process by itself. So by looping it around, what you end up doing is you basically iterate through all the processes in the red and black tree that as I learned, is the scheduler, and it ends up running through each of the processes, and then if it has nothing left to run, it goes to the idle as we're supposed to have. And in order to know what level we are currently in, you do a little bit of remainder math. So you take this clock and the allocation times that you're given, and basically by finding the corresponding ratios, you can find whether, if it's basically smaller than the allocation of the first, then you're in level 0. If it's smaller than both the first and the second, you're in 1. So first, second, third, fourth, etc. And that's how this works.